If you're not familiar, NOAA is the National Oceanic and Atmospheric Administration, a federal agency dedicated to understanding and predicting changes in climate, weather, oceans, and coasts. Today, we are introducing you to Sara Morris, who will be talking about the Arctic and the MOSAiC Expedition. But before we start, we would like to recognize that we are all coming to you from the traditional lands of Native communities who have substantial traditional knowledge to share with us. We acknowledge that our speaker today is presenting from the lands of the Arapaho, Cheyenne, and Ute nations in Colorado. Sara, go ahead and take it away.
Great. Thanks everyone for joining. I'm Sara Morris. I sit at the Boulder Labs, NOAA Labs, at the Earth Science Research Laboratory. And I want to talk to you guys a little bit about my Arctic research and specifically the MOSAiC Expedition. And MOSAiC is an acronym, and it stands for the Multidisciplinary Drifting Observatory for the Study of Arctic Climate. So it is a mouthful, but let's get into it. So a little bit about me. I am a Colorado native, born and raised in Colorado, from Montrose, Colorado, actually, a really small town on the western slope, and then moved to Boulder to go to my undergrad at CU. I studied environmental science with an emphasis in climate, and I minored in atmospheric oceanic research. And I have been at NOAA for about over 12 years now. And about 5 years into my work at NOAA, I wanted to go back and get my master's and further my education, since I found my passion, which was Arctic. And so I went back to CU into the geography department and did my master's thesis on the Arctic region and energy fluxes, which I'll talk more about later and what that is. And then continued to work while I did that, and have been at NOAA for quite some time. I've been in three different labs. When I first started, I actually was in the National Geophysical Data Center, which is now NCEI. Thank you. And then, so I was there for about 6 months, just as a temp position. There was an open call for someone to digitize their library, their scientific library, and I just wanted to get my foot in the door because I knew I wanted to be at NOAA. So I took that little temporary position and then networked like crazy and got a job at the Global Monitoring Lab in their ozone department for about 2 years, and then started to learn more about Arctic research and found a little Arctic bubble of people in Physical Sciences Lab, which is where I sit now. And so I migrated over that way and have been there ever since. But yeah, I have 2 daughters, Avery and Sandy. There's some cute pictures here. Avery just turned 4 and Sandy is, she'll be 2 in February. So we are quite busy, but we're doing it all. So a little bit about my research. So as I mentioned, I work for NOAA under the Oceanic OAR, which is Oceanic and Atmospheric Research branch. And I specifically work under the Arctic Research Program, which we refer to as ARP. I look at weather and climate, and for those of you that don't know, climate is just essentially weather over a long period of time. And so when you think about other states and what their general climate is, so like Florida, humid, more summer, and you think of California, summer all the time, and then Colorado's climate, we have all 4 seasons. So those are the different types of climate. But that's generally what we look at, and we do look at this mostly in the Arctic for my little POP group. And POP is the Polar Observations and Processes team, which is the team that I'm a part of. And so we like to do anything and everything Arctic. These are a few photos that I've taken of myself in the field, and we get to go into the field, I want to say, like generally once or twice a year. COVID has kind of paused that. We're all just starting to come back after a few years of not going anywhere, so we're really excited. And MOSAiC actually happened right during COVID. So MOSAiC, the expedition happened, and then a few months in, we had COVID. And so that was really interesting to navigate an expedition during a pandemic. So I'll talk about that more as well. Some of these pictures, so the one on the far right with me on a ladder in this really wintry environment is in Alert, Canada. That's our northernmost station that's on land that we have. And so it's as far north as you can go on land before you hit the ocean. And then the picture next to that one is me and some colleagues in front of the Polar Stern, which is the icebreaker that we took on MOSAiC for the expedition. So we're all getting ready to go out into the fields. And then the picture next to that is also on the inner decks of the Polar Stern. And then the one on the far left is at our research station, the U.S. research station in Barrow, Alaska. So that's our U.S. Arctic station, and we were working in the lab before going outside to deploy. So here's a quick overview just to orient yourself with where the Arctic is. So I put a little arrow here for Boulder, Colorado. And I know some of you might be sitting in other places in the US, so go ahead and find your little dot if you want. But in Boulder, if you just went straight north, you would hit this Arctic Circle. And you can see Utqiagvik, Alaska. That's where our Barrow Observatory is. And so that's the US Arctic site. Alert Canada is the one that I've been at, which is that northernmost piece of land. And you can see that it is, I should have put a little dot marker for where North Pole is, but the North Pole is actually in the ocean. It's on, well, in the winter it's over sea ice. And then my first experience out in the Arctic was actually in Tixi, Russia, back in 2012, and that was a really interesting experience just because it took us so long to get there. And then Tromsø, Norway, which is where we the MOSAiC Expedition took off from. So that's where the boat was docked, and we loaded everything up in Tromsø, Norway, and then it headed out. So, and I'll have a map of the MOSAiC ship track as well at the end. So just a brief overview here for everybody for why it's so cold in the Arctic and some interesting features of the Arctic. So as we all know, the Earth is tilted, and so with that, as we rotate the sun, there will be periods of time where the Arctic is either fully in the dark or fully in sunlight. And so I put little pink kind of red stars here where the Arctic is, so you can kind of tell when the Arctic is in, we call it polar night. So when it's dark 24/7, the whole day long for several months. And it's during those winter seasons. And so I think the sun goes down in late October, depending on where you are. And then it doesn't come back up till March. And so or February, March. And so you're in the dark for a long time. And then likewise during those summer months, you have daylight 24/7, which is really, really interesting. And I've been in the Arctic in both instances. When it was dark 24/7 or when it was light 24/7. And I think I actually prefer the light 24/7 because you can darken the shades or your windows or whatever to make it feel like it's dark and get some rest. But when it's dark all the time, it's really hard to wake up and get your job done. And so you feel kind of like, you know, drained a little bit, you're tired a lot. And so that was my experience. And so I know that differs for different people, but that was something that I experienced was pretty interesting. So here's some pictures of what it looks like in the Arctic during those two seasons. In the summer when it's daylight all the time, it kind of feels like a normal kind of fall, I would say fall winter climate in Colorado even. So you could wear your jeans and like a long sleeve shirt and you're fine. And you can see there's grasslands here. So this is the Tixi, Russia site. So it's kind of rolling hills. It's very marshy and like kind of the earth is like a sponge, and that's our permafrost. So has a lot of moisture in it. And then when that freezes, it becomes really hard as ice. But you can see it's kind of mossy. It's really wet. We wear galoshes everywhere we go. But you can see you wouldn't expect the Arctic to look like this necessarily. Lots of greenery. But you will notice there are no trees, and that is because of the permafrost. So trees and their roots can't get down into the soil enough for those winter months when it would just freeze and kill the tree. So that's one interesting feature I would say of the Arctic is there's just no trees. There's a lot of shrubs or grasses. And then in the winter is the lower picture, and that's in Alert Canada. And that's when there is no sunlight all day. This was in October, so you can see we have some twilight where the sun has just set, and so you can still kind of see like a horizon. It looks like, you know, your normal sunrise or sunset you'd see in the US, but it just stays like that all the time until it goes fully down and then it's pitch black. But there's lots of snow and ice, and it's difficult to even differentiate between because a lot of these sites are on the coast. So you'll be walking on the land, and then as soon as you can walk over the ocean and not necessarily know it all the time, because the ice is just, you know, an extension of the land. And so it's hard to differentiate when you're on ice, or sorry, over water or land in the Arctic. So let's get into the MOSAiC expedition. So this is a snapshot of the experiment. This is our idealized version of what it should look like, and I'll go into what it ended up looking like. But we've got our boat, the Polarstern, and as I said, we took off from Norway and we sailed as far north as we could to find what we call an ice floe. So it's a big sheet of ice that is strong enough to hold all of our equipment and that we can walk on. And so we want it to be a really thick piece of ice. And so the big thing there was to find the right ice floe. So there was a lot of navigating in the Arctic to try to find one that would work. But once we found our floe, we would go and deploy all of our experiments across the ice floe. And then we were meant to take some measurements in the air. So we were supposed to have aircraft flights, but those were canceled due to COVID, but we still had some balloon launches that we could do. And then we measured a lot of things below the ice. We were able to drill down. You can see this ROV city, and you can see an ocean city where they're collecting measurements below the ice. So the gift of MOSAiC was to collect data on the ice, above the ice, and below the ice. So it was really to capture this full scale of what the Arctic climate would look like. And so we had 5 major teams. I was part of the atmosphere team. We had a biogeochemistry team, an ecosystem team, an ocean team, and a sea ice team. And so you can kind of see those laid out on this ice floe here. Met City is part of the team atmosphere. So it stands for meteorological city. So it's all of our met measurements like wind, pressure, temperature, humidity, things like that. And energy fluxes, which is just a flux is just essentially like a change in temperature, so an exchange of energy. And so I'll go into this. I have lots of fun pictures, and I will I am guilty that most of this presentation is just really cool pictures from the experiment because it was just so fascinating. But this is the Polarstern. It's actually kind of hard to pick out, but it's in that lower middle part there. And that is, you know, kind of chunking through the ice trying to find our floe. And there's lots of these what we call open leads, which is what, you know, looks like a river where the ice has kind of come apart. And it's just slow going. So you slowly make your way through the ice. It's a very loud and slow process. And here's some pictures that my colleague Chris Cox took. You can see that picture where you can see all the, you know, the trail that the icebreaker has kind of gone through when it's chunking through ice. And one interesting thing that I actually learned about icebreakers is they don't really like ram the ice to get it to break. They actually rise up on top of the ice, and the weight of the icebreaker like sets on it, and it kind of breaks it that way. And then it'll kind of back up and then ram up on top of the next one, and then the weight of the icebreaker will break the ice. So that was an interesting thing I learned. But that whole process is super slow and very loud. So I've been told. But this is a picture actually of Chris Cox. In this picture, he's on the right, and so they're just kind of watching there's 2 ships going out for MOSAiC, and they're watching the ship ahead of them because we had so much equipment. So when we first deployed, we had the Polarstern, which is the main ship that was going to stay out there the whole winter, and then, or the whole year. And then the other ship was a Russian icebreaker that just followed us with all of our equipment because we had to drop things off on the ice floe, and it was easier to do it that way. So here's a picture of Polarstern. It found its ice floe, and so you can see even the little trail. It looks like a little river, and that's kind of the trail they came in on. But this is their home on the ice for the next year. And so the goal, like I said, of MOSAiC was to collect data for an entire year on this ice floe, and that's never been done before. We've collected data for a few months, but it is really hard to do this in the winter because the sun is down. It's incredibly difficult physically for the scientists, but also for the instruments and for the transport and logistics. So yeah, this was our first go at it, and it went really well. But you can see there's 2 cranes on the ship. There's one in the front and one in the back that you can't see, but that's how we offload all of our equipment, and then we kind of run them on ski-doos all the way out. And you can see these little flags if you look really close, and those were kind of our like little highways that we would follow. our tracks so that we didn't disturb the ice, and we would always use the same track. So yeah. So here's a picture from my other colleague, Matthew Shoup, and Dr. Matt Shoup, he initiated the U.S. part of MOSAiC. So he is one of the grandfathers of MOSAiC, I would say. Marcus Rex and Matt Shoup were the kind of the two leads on this project. But Matt has some really great pictures. This was our team walking out to one of the sites. So this is during polar night. So you can see it's pitch black and it's very windy and very cold. And so everyone's in these, they're called like Mustang suits, and they're just these red suits that are supposed to be warm enough so if you did fall into the ocean, you could survive for about 2 minutes before someone could pull you out. And so they have lots of reflective features on them, and they're red, so you stand out against the ice. So, and you always work in pairs, or even more than one, because you never go out by yourself. And so you can see here they're using the ladder because a lead opened up, so there's the ice pulled away, and so now there's an open kind of little creek of Arctic Ocean below them. So you have to be really careful when you're working out on the ice. So this is the setup, one of the many setups. This was Met City. So we had to construct a building while we were out on the ice. And so, you know, the easiest way to do that, the easiest way to ship it was to break everything down and then build it when we got there. So you can see everyone here making a little kind of trailer to host all the instruments inside, and then they have these little inlets that sample the air that's outside and bring it in to collect the data. So that was a big challenge. It took several weeks for everyone to get all of their equipment and their buildings set up before they could start, you know, collecting data continuously. Here's Chris Cox working at one of our stations that we deployed, which is the Atmospheric Surface Flux Station, and I'll show you more about that as well. And Chris has his little computer out there. He's running some diagnostic checks because the instruments don't like cold weather, so you have to check on them often to make sure they're still working. And so you can see a lot of the buildup on the railings here, and even on some of the instrumentation you can see. But it's super cold and difficult to work in. But Chris was a trooper. He was out there during most of probably the longest leg, which I'll get into during MOSAiC. So he was out there for quite some time. And this is this is called a flux tower. So this is one of the features that sits at Met City. You can actually see the boat in the background there. But this tower, it measures different meteorological data points at different levels in the atmosphere. So you can kind of see these booms at the 3 different levels on the tower. And so that's to get the profile of how temperature or wind is changing as you go up and down the tower. And so that gives us an idea of what the atmospheric structure looks like, how winds are spinning, how temperatures are changing. And just, yeah, I think this is a 10, 12 meter tower. And this was one of 2 towers that we had at MOSAiC. The other one was 20, it was huge. It was like 20 or 30 meters. So 2 or 3 times the size of this one. But I'll get into that one. That one was challenging. But anyway, it took several people to install this guy, and just, you can see all the guy wires off of it to keep it stable. And yeah, so this was what my team works on, are these flux towers. And then the ASFS, or the Atmospheric Surface Flux Station, which I mentioned earlier. So this is essentially a mobile tower. And so what we did is that tower is, you know, it has the guy wires, it's a full structure, it's not going to move. It's at Met City, it's very stable. And so we couldn't install these towers all over the ice because they're not mobile. And so with the ice moves a lot. And so we need to be able to move our systems. And so we were only able to have the one tower. And so we developed these ASFS stations. And so they're mobile towers essentially. So we put the tower, we deconstructed it down to just the one level, and we can kind of push it wherever we need it to go. And so we had 3 of these out on the ice floe, and then 1 spare. And so, so we had on the ice at any given time, hopefully 3, but some of them, I'll get into the challenges that they were crunched up with ice. But this is a really fantastic picture from my coworker, Michael Gallagher, who's also a photographer, which is amazing. And he took this really lovely picture, and he was out at MOSAiC during like 2 which was during polar night, so that it was dark the whole time, and you can see all the ice buildup, and it was really, really intense to work in, which was really cool. So we're going to get into some of these challenges we had with the ASFS, which was, exciting and kind of a fun perk of the job, is to be creative, and when these challenges arise, how are you going to, get out of them and figure it out. And so one thing we had to deal with during the kind of early and later portions of MOSAiC, because it's a full year, was the melt season. So when the ice starts to warm and thaw, you get these melt ponds and these little rivers, and you have to move your systems, out of the way. You don't want them to sink and melt and go to the bottom of the ocean if you can avoid it. But we can't visit these stations all the time. So the point of these ASFS stations, so we have our humongous ice floe, I think it was 20 kilometers wide or in diameter. And we had 3, and we wanted them to be kind of at the edges of the ice floe, with the ship and Met City being a 4th station, and then everything else going out from that. And so these are called autonomous stations. So they run without direct connection to electricity to power. And so we had to be able to power them without like running a cable all the way back to the ship, which wouldn't be possible because it was too far. And so what we did was we used, there's this company that you take methanol, like jugs of methanol, and it'll actually convert it into energy, into like, and it'll fill up like a car battery, and then we use that to power all the instruments. So so we didn't have to visit these sites every day. I want to say it was like once a month or every 2 weeks that we would visit these stations just to check on them. Or if we saw something in the data that looked off or suggested that there was some problem, like it had tipped over or something, then we would go out and visit the site. And so, but yeah, one of the things was to move these things out of the way when we knew that there was melt happening in the area. And so that was a big challenge. During that winter months, I mentioned that the ice can crunch up one of the ASFSs, and so we get ridges, and that's when 2 pieces of ice come together and just make like a little mountain, a little ridge. And so those ice ridges are like cement, so they're really, really difficult to kind of hammer away at and get your stuff back out. And so that was and they happen very quickly. And so overnight, one of these ridges happened, and it tipped over our ASFS station. I think that's Michael Gallagher in the picture here. Or maybe he's the one he might have been the one to take the picture, but this is his colleague anyway. But you can see the whole sled is totally tipped over. And so it took them, the way I understand it, 2 days to get this thing chunked back out. So they had axes and chainsaws, and they were trying to kind of eat away at the ice to get the thing to flip back over. And I couldn't show video on this. I would love to, but I do have, Michael shared a really cool video of them kind of using some pulleys and flipping it back over, which was really cool. But this was definitely a challenge. During one of the legs, I think it was the same leg, the leg 2 during this polar night, another one of the ASFSs got crunched up with the ridge, and it was not salvageable, and so that one was destroyed. And so these ridges they mean business, and it was unfortunate that happened to us twice, but at least we got one of them out, and we were able to salvage it and get it back out on the ice to collect data, which was great. But the other one was totally gone, and you couldn't get it back out of the ice. So it was really interesting. And that's the moon in the background, if you're curious. But one of the more interesting challenges was polar bears. These are all pictures of polar bears that were at MOSAiC and arrived at the boat. And so this was a mom and her baby here, and they're just kind of sniffing out, and they're kind of curious. We had bear guards everywhere you went. So if you ever left the boat, you had to have a bear guard with you, and their only job was to keep watch, because polar bears, for as large as they are extremely quiet, and they're very stealthy. And so you need to have someone designated, just, their only job is to look for the polar bears. And they come at all seasons. So it doesn't, polar winter, when the sun's down or daylight, it doesn't matter. So there was someone always watching. But they were definitely curious, and they played with some equipment. And I have an interesting video again that I wasn't able to show, but they did tear off one of our our exhaust pipes off of the ASFS. And we think it's because the exhaust for the ASFS is actually water. It, you know, once the methane is converted, it exhausts water. And so I think they were trying to drink it. That's all we can guess. And so they ended up ripping it off, but we were able to replace it. But yeah, they're just really curious. Obviously we're in their environment and they're like, what are you doing? So but these are really some interesting and cool pictures of these polar bears. And I wanted to highlight for you guys one of the transitions. So I've been talking about these legs that we had during MOSAiC, and there were supposed to be 6 legs, so 6 different sections of, you know, where we would swap out equipment, swap out personnel, crew. And so there's supposed to be, you know, I think 2 to 3 month chunks that you would be out there, and then you would rotate with the next crew. COVID made that really tricky, and so we ended up not being able to swap as frequently as we wanted. And so legs 2 and 3 ended up going a lot longer than they were meant to. And so kudos to the crew and researchers on those legs, because they were out there for 4 to 5 months. They were out there for a long time. And so it was really, so anyway, so we had 5 legs on MOSAiC. But this was the leg 2 to 3 exchange. So these were the people that had been out there for quite a while. And it took a long time for the other boat to get to Polarstern, because this is in the dead of winter. So it's really cold. The ice is a lot thicker. It takes longer for the icebreaker to chunk through because it's so thick. So it's just really slow going. And so this was another Russian icebreaker that you can see in the foreground here. And then Polarstern's in the background. And so usually the ships could pull up right next to each other and exchange crew and supplies and everything, and it would go pretty quick. But for this leg 2 to 3 exchange, this was as close as the boats could get, and it was about a mile apart. Well, maybe a little bit less than like 1 kilometer apart from each other, so a little less than a mile, and everyone had to walk. And so crew and scientists had to get off of the Russian icebreaker and walk all the way to Polarstern, which was, I mean, that's not that far, you know, a mile, but when you're freezing cold, it was, you can see the temperatures here, -72 Fahrenheit. Very, very cold weather, and you also have to worry about polar bears. And so that, you know, they had to scope out a lot of things. Getting people across wasn't as hard, but getting the equipment and the fuel and the food and supplies across the ice was really, really taxing and took a lot longer. But this was a really exciting and energetic transition. Everyone was in really good spirits. But there were 83 scientists and crew that were exchanged between the boats, and 43 tons of cargo. And then a nice little note here, the Polarstern did actually reach the North Pole during the expedition, but they did it in the summer months when that ice was at a minimum here. So, but yeah, so this was just a really, I thought, fabulous photo that just shows how kind of extreme this whole project was. So, and then here, just to show you guys, these are all the people that were on MOSAiC. So this was the leg 1 participants. You can see this was during polar night. This was right at the beginning. This was the first beginning section, first few months of MOSAiC. And you can see all the people. And then this was the leg 2. So these guys were out there the entire time in darkness. So the sun was never up at any point for these guys. And they were troopers about it. They had really great attitudes, and they were hard workers, and it was freezing cold. So they were really amazing. And then leg 3, this is where they had some polar night, but then the sun rose in about March, and so they did have some sunlight. So leg 2 is the only one that didn't get any sunlight. But here's the folks from leg 3. They're all excited because the sun's out. And then leg 4, you can see we're starting to get melt, and so you can see some melt ponds and rivers starting to form, and the ice is starting to break up. And then the final leg was leg 5, and this one, they found their last ice floe before it completely disintegrated, and so they took this photo, which was really cool. So that was our last leg there. And I just wanted to show you guys some of the data that we're looking at that we've collected from our ASFS station. So this is just in order from top, read it across down to the bottom. And this is temperature data, so super simple. And it's broken up by the different legs that were collected, so you can kind of interpret some interesting things just by looking at this. So sorry, the scale is really, or the key is really hard to read, but the first 3, so there's red, orange, and kind of a maroon, and those were the 3 ASFS stations. And so at the beginning, this top panel kind of on the left, you can see all three colors. And then as you go, you see the ASFS kind of drop off as they were either crunched up or they were tipped over, or they, had the power went down or something. So you can kind of see it was really great that we had three, because then at one point, at least something was working. One of them was on, but you can kind of tell that story as you go through the data, even seeing all the instruments and how hard it was for us to even just collect this data. But yeah, you can kind of see, so like the coldest temperatures here were the like 2 to 3, where it's down to -40 here. These are in Celsius, and then it got warm, but I think the warmest, it was like maybe, I don't know, 30, well, like 30, I'd say like 30 degrees Fahrenheit would be like 32, so about freezing, which was really interesting. And then, yeah, I wanted to point you guys all to there's some great resources. There's a CU Boulder MOSAiC page. There's a NOAA MOSAiC page. And then there's an AVI MOSAiC page. And AVI is the Alfred Wegener Institute, and they're the ones that ran the Polar Stern. So they're a German institute, but they have that kind of main homepage. And I wanted to post, I'm gonna escape this really quick. And I wanna show you guys, I think I have to stop sharing my screen for just a moment, but I wanna show you guys the ship track if I can. So give me one moment to stop sharing, and then we'll share a different screen here. Okay, here we go. Is everyone able to see that?
Yes.
Hopefully, okay, cool. So this is at the AVI page. So this is if you Google MOSAiC Expedition, you would come up with this page, and it has a main page. But then if you scroll all the way to the bottom, it says like a little tag that's follow MOSAiC, and it was like an Instagram, Twitter thing. And so you can see this gray line here. I don't know if you can see my cursor or not, but here's the beginning. Let's see, it shows where it's at now, so that's where it ended. It ended in Germany, but it started in Norway, and it took off, and you can follow this kind of gray line, and then you can see how it got all the way to the North Pole, and I think we hit, let's see, when did we hit the North Pole? Let's see, that was in the leg 5, so that was right at the end, and that was when things started to disintegrate and the ice kind of started to come apart a bit. But yeah, so you can see this ship track, and the reason it's so kind of loopy is because the ice moves while you're on it, and so it would there were portions, the first leg even, where we had set up Met City, here's Polar Stern and the Met City's to your right, and then people woke up the next morning and Met City was sitting in front of the boat, where the ice had totally shifted around the boat. And so there was a lot of that going on. The ship flow was very active, and so that was really exciting. As I mentioned, we had, some of our ASFS stations were crunched up with the ice, where it had ridged or it had come apart in one case, and we actually lost one of our ASFS in the ocean, which you hope not to do, but that happens. But yeah, and then in that melt season, they did the flow that they chose, that ice flow, actually did disintegrate completely, and they had to put everything back on board and then go and then kind of cruise the ship over to another ice flow and then reset up camp, and they did that twice, which was really exciting. So, but yeah, so I'm gonna click over here, and I think that's all I've got for now, but let me see questions in the chat if I can.
Okay, we do have one question about weather, and can you compare weather in the Arctic with the Antarctic? Do you know if around the South Pole it'd be colder?
Sure, yeah, yes. So so they're both really, really cold. I believe the South Pole is a bit colder though, and the reason being is, so the Arctic is over ocean, so it's the Arctic is essentially an ice sheet. So it is, if you go to the North Pole, you're over the ocean, you're over an ice sheet. If you go to the South Pole, it's a land mass, so it's a continent, and so land is actually, it's going to be colder than the ocean, and so it gets a little bit colder than the Arctic does. Yeah.
One of your photos had really pretty stars. Did they see a lot of stars and aurora in the winter?
Yeah, tons of stars. The Arctic is actually relatively cloudy, unfortunately, and so you don't see, well, at least see, it might only be during the transition in the summer months where it's really, really cloudy. But I think in the polar night, they got to see a lot of clear skies, and the moon made it actually really bright, which was great on those clear nights. But they did see some stars. I don't believe they saw some aurora, but I think it was only on the transport ships, like to and from. And so it's the aurora tends to form at like a certain latitude, and it's not always directly right at the North Pole, surprisingly enough. It's kind of, you know, further down by that Barrow, Alaska type of region. So yeah, but they did see them. But like I said, it was on the transport ships mostly. So
That's interesting.
yeah.
If you all have any other questions, go ahead and put them in chat. There was a question about your equipment, which you then kind of answered. But so that one piece of equipment that was caught up in the ice, is it just in the bottom of the ocean now? Is it still in ice?
Yeah, one of them is. The ice melted and it sank, so it's goner. But the other one, we were able to kind of chisel it out and get it out before that happened. Because a lot of what happens, even in the winter time, is it ridges, but then it'll come back apart. And if you don't catch it in time, it's gone. And so the difficulty with these ASFS stations was they were not right by the ship, so we couldn't easily get to them. You had to actually take a helicopter out to them to visit them. And so if you couldn't, if the weather was bad or it was too cold for the, you know, the propellers, you know, whatever, then yeah, sometimes you would miss it and you wouldn't be able to get to it. But yeah, so it's in terms of like the instrumentation that's kind of sporadically like clipped on to that sled that we had. We deal with the rhyming, we call it rhyming, which is like frost essentially that forms on the instruments. We have ventilators, so that's just like if you like put a little mini fan and point it at the instrument, it's actually enough to like keep most of the ice off. So we call that aspiration, and so we aspirate a lot of our instruments. So we have little fans running constantly, and so that keeps the ice off for the most part, which is really cool. And then we've also a lot of industry folks, the people that we buy these instruments from, have experimented with kind of the way they shape the housings. So the you know, whatever they put the instrument inside of, they kind of change the way it looks so that the ice doesn't form on it quite as much. And then we did visit them. Like I said, it was like every 2 to 4 weeks. And so when we would go, we would, you know, dust off any ice if we saw it on the instruments. But then at Met City, that flux tower that we saw that was really close to the boat, that we visit every day. And so we were able to clean those instruments every day and make sure they were not frosting over or whatever. But it's a little bit more challenging with those stations that are further from us. But we've done a lot of experiments and studies before MOSAiC to kind of prepare to make sure we could keep all this ice off of our stuff, because you don't want to collect bad data. So we invested a lot of time in making sure that everything was clean and accurate. So
wow. And so people had bedrooms on the ship and ate on the ship. There must have been some chefs and a lot of people of that nature to help out.
There were, yeah. So it was a German-run ship. So it was the icebreaker was owned by Germany, and so all that meant all the crew were German. And so that was what was really cool about MOSAiC. I think there were 20 different nations involved, and so there was a lot of different languages being spoken. And so you know, communication could be challenging at times, but everyone was super patient with each other and used Google Translate or whatever to communicate with each other. But it worked out really well. But a lot of, you know, German cuisine, so lots of German food, which was fine. I mean, it was all great. And then you could bring some of your own things, obviously. And then there was a doctor on board in case anyone got hurt. I think the only injury I heard of was someone broke their foot in the first leg because they slipped. The ship gets really icy on the outside as well. So if you're going up and down those stairs, and he just slipped, and then he came out on that next leg, and so his partner ended up staying there for 2 legs to you know, make sure that they had someone on staff to deal with their instruments. But yeah, so there was a doctor, there were chefs. There was a little pool inside, like that you could play, like a swimming pool. There was gym equipment. There's like a little store that you could buy like hats and MOSAiC shirts and like, so it's similar to, I imagine, being in kind of like a military Navy situation, so there's some amenities, but you definitely are very confined, and everyone gets to know each other really quickly because there's nowhere else to go. So yeah.
Were they able to communicate with their families?
Via email. So there was no phone, but you could send emails, but generally you could only send really small emails. So no like pictures could go out very much. And so it's like a lot of just like, yeah, emails, which is why I felt bad for that leg 3, because they were out there for, I mean, almost twice as long as they were supposed to be because of COVID. And like I said, the reason for that was just a lot of borders and ports and docks were shutting down with COVID. They didn't want people, coming into their, so everyone was shutting down their ports. And so, the icebreaker that was supposed to come out couldn't come out, and it was a whole thing. And so, but yeah, COVID really kind of messed with us a little bit, but everyone, oh my gosh, people were just such troopers, and everyone handled it and they were great. But yeah.
They must have had to quarantine then, those later legs before they left.
Yeah, I'm glad you mentioned that. Yeah, so quarantine was 2 weeks, and you would, leave the US, you'd have to quarantine, and I think generally it was either Norway or Germany, one of the two, depending on where the ship was coming from. And so you'd fly there, you'd quarantine for 2 weeks, and then you'd be on the boat for like 2 to 4 more weeks, just trying to get out there, because it was such a slow go with the ice being so thick. And so you'd be in transport to MOSAiC for a month and a half before you'd even get on the boat. So it was quite a process. And then for the folks coming off, they would take them another 2 to 4 weeks for the icebreaker to like chunk back out of the ice, and then they'd hit the dock and then have to quarantine for 2 more weeks before they could fly home. And then in the US, they'd probably quarantine for another like 10 days. So there was a lot of logistics for everybody. And none of us could have prepared for that because no one knew this was coming. And so it was a true testament to the logistics teams, I would say, for getting, for just being ready on the fly for, handling this type of situation. It was really interesting. But
it's amazing. Yeah, it's great that it still happened and worked out. So yes. We almost are done. Can you just tell us what sort of things are you doing currently with NOAA and Arctic research?
Yeah, so like I said, we've been kind of on hold with travel, but we're still collecting data at all of our sites. They're still working, and there are technicians that live out there on all of our coastal sites. So we have, that first picture I showed with all the sites that I've been to are on the coast, and people actually live at those stations and take care of them. So all of our stuff's still running, which is really good. But I haven't been out to the Arctic, since this. But we had a few colleagues go out to Summit Greenland just in this summer in June, which was really exciting. But they also had to quarantine still. And right now what we're doing actually with those ASFS stations, those little sleds that I showed you, they're all back in Colorado in Boulder, and we've deployed them on this we call them campaigns, but it's an experiment called Splash in Crested Butte, Colorado, up over by Gunnison. And so it's up in that high alpine, doing the same thing. It's just collecting all this like MET measurements and fluxes. And when I say fluxes, there's a few different kinds of fluxes. So we collect radiation fluxes, which is like the sun's energy, so like changes in the temperature essentially. And then we have turbulent fluxes, which is wind energy. So, and then or CO2 and methane gases, gas energy as well. And then ground heat fluxes, which is the soil. So how does the soil change in temperature throughout the year? And so those are our fluxes, but that's what that station does. That little ASFS sled it measures all those different components. And so it did that at MOSAiC. The 2 that came home out of the 4, the 2 that came home are now redeployed over at Crested Butte. So, and they'll be there for another year, and then they'll come home, and then I think they're next going to Summit Greenland onto the ice sheet, and but they need to be refurbished, and we have to replace instruments and kind of get it ready to go again, because it takes a beating, if you couldn't tell. So
wonderful. Well, Sara, thank you so much, and everyone, thank you for joining us. If you can join us tomorrow, we'll have one more talk tomorrow. Thank you.